But these obstacles give rise to opportunities, I think, and what I'm going to concentrate the rest of my presentation on is what I think some of these opportunities are. So despite the individuality of ecosystems, there are characteristic regularities that exist in the macroscopic patterns, whether you're dealing with forests or freshwater systems or marine systems. There are certain features that we recognize, and those are the features that sustain what we call ecosystem services that are important to the way we utilize these systems, despite the differences in detail. We can't be concerned with maintaining every feature of every system because they change naturally, but there are certain macroscopic features we need to identify, and those should be the focus of research on sustainability. So to get there, that means we have to know how to relate phenomena across scales, which is where most of my work is, from cells to organisms, from organisms to groups of organisms, from those groups of organisms up to ecosystems and the biosphere. And they ask questions like, how robust are the properties that we depend upon? How does the robustness at the macroscopic scale depend upon finer scale dynamics on ecological and evolutionary time scales? And are ecosystems at critical points where they're in danger of collapse or sudden change? Are we about to lose the general circulation patterns of the oceans, et cetera? So much of my research and much of the research in theoretical ecology has been directed at trying to understand the macroscopic features, like in this forest system, in terms of the dynamics of individuals, like the trees that make up this system. This is work we did about almost 20 years ago, but based on the work of many other people like my colleague Steve Piccola, Dan Botkin, and Henk Schugert. Models of this sort are very good at predicting some of the statistical properties of the distributions, but not obviously where every tree is going to be. Indeed, vegetation models that extend these up to the global scale explain global patterns, but not individual species, but going back to that slide I showed earlier of the kinds of vegetation one would see in a particular region. And people have applied models of this sort to other systems. Mick Follows, working with Penny Chisholm and others, has developed a model called Darwin, which makes predictions about where one might find ecotypes, groups of species, diatoms, large eukaryotes, not individual species, again, but these models have been very successful at predicting in testable ways the distribution of organisms on the planet. And we've been working with Mick and his group to try to look at this in an evolutionary perspective. So ecosystems and the biosphere are indeed made up of these individual agents. They're what we call complex adaptive system. This wonderful movie given to me by Claudio Carreri is of starlings in Rome. Well, all except for this hawk that you can see here, which is driving this whole behavior. And so we have a large, if you're a fluid dynamicist, which is where I did my training, you look at this and you say, I have to be able to model that as a fluid. How do these macroscopic patterns emerge when individuals are simply paying attention to local conditions, to their nearest neighbors, for example? Complex adaptive systems are systems like this, heterogeneous collections of individual agents, and could be in the stock market as well, that interact locally and evolve, I don't mean in a genetic sense, but change based on the outcomes of those interactions. And this is a novel way to look at these systems. You saw my slide earlier talking about the management of forests as complex adaptive systems, a new paradigm that seems to be emerging. But not only the ecological systems, but also the socioeconomic systems with which they are linked are complex adaptive systems made up of individual agents. In 2008, working with colleagues Robert May and George Sugihara, and coming from a meeting on systemic risk that was held at the New York Fed, we published a paper in Nature that said, we're just humble ecologists, we don't know much, but it looks like there's a lot of common ground between financial systems and ecosystems, and if we were working on your systems, we'd be worried. We said, who knows, for example, how the present concern over subprime loans will pan out? So this was 6 months before the market collapsed, and then the market collapsed. So as I told people last night, I wish, in addition to writing this paper, I had read it and, and believed it. But indeed, the market collapsed, and not because of our paper, but I think because of the reasons we identified. The system had become overconnected. So there are great parallels between ecological and economic systems. Many such systems, many such transitions have characteristic early warning signals. Martin Skeffer has published a book, actually in a series I edit, on critical transitions in nature and society, and various groups with which I've been involved been working together to try to determine what the early warning indicators are that systems may be on the verge of collapse, in the hopes that if you can read those signals, you can step back from it. And I don't have time to talk about this in detail. There are some promising signs, and there's also the danger of over-interpreting some of these signals, but I think it's a very exciting area for study. Scientific consensus on many of the issues that all of us are concerned about is strong. For example, in terms of climate change and the increasing temperature, and yet we haven't done enough to address that. Why? I don't think it's because we don't have the scientific knowledge. Of course, there are aspects of the science that we don't understand, but this is not the primary limitation. The primary limitation is on the side of the social sciences, on the side of the willingness of people and governments to commit to the common good, and to cooperate in finding solutions that benefit everyone. So I think that's where the great challenge is, and that's where I'm going to spend much of the rest of my time today. The central issues are issues of behavior and of culture. My colleague Paul Ehrlich has led the development of something called the Millennium Assessment of Human Behavior, which says this is the key thing in dealing with environmental problems. We have to understand why people make the decisions they make, what the role of collective decision-making is, in the hopes that we can influence these decisions. So these involve issues of equity, both intergenerational and intragenerational. I'll talk about both of those briefly. These involve problems of public goods and common pool resources. Public goods are things like clean air that we all share, and differ from common pool resources only in the notion that with a public good, my use of it doesn't limit your ability to use it. Common pool resources would be things like fisheries. How do we get cooperation in the commons? What's the role of social norms and institutions and agreements? Foot binding was widespread in China among certain classes for centuries, but then, and very robust, but then suddenly disappeared over a very short period of time. How did this social norm change, and what can we learn from how this changed, how attitudes towards gender equality, smoking in public, racial equality changed in this country? There are examples where attitudes have changed. Indeed, in 2008, before the crash, Jeff Sachs, an economist at Columbia, came and lectured at Princeton, and he said the attitudes were changing. People were accepting that climate change was a serious problem, that humans were responsible, we needed to do something about it. But then the financial crash came, and suddenly these issues were placed on the back burner. There was a dramatic attitudinal change. I'll come back to that in just a moment. We also have to understand how we develop these consensus. So this is what I wanted to indicate to you about attitudes. This is a study that came out of RFF, of which I'm a so-called university fellow. And I don't know if you can see that. Do we need to turn the lights off here, or is this, it's okay. So this is a study carried out in the US, in China, and in Sweden. And the question that was asked is, do you believe that temperature has not increased globally? In China, only 5% of the people thought that that was true. 95% believed that temperatures were increasing. In Sweden, it was 94%, indistinguishable. In the United States, 24% thought they had not changed. So way down, 76% believed that this was a problem. It gets worse. What percentage believe that humans have affected temperature increase? In China, 96% thought humans were responsible. In Sweden, 94%. In the US, only 73%. What accounts for this? Well, obviously, we have to do a better job of informing and understand the culture and how this has happened. And finally, should we prioritize environmental improvements even if we lose jobs? In China, 77% said yes. In Sweden, 62%. In the US, only 40% regarded this as important. So obviously, it's culturally dependent, and understanding why will help us to understand what we have to do about it. One of the issues is equity. we discount. This is a picture my wife took of me not too long ago. You know, I know I shouldn't overeat. We all know we shouldn't overeat, but when it's in front of you and it looks good, you're tempted to eat. So we discount the future. And that's very important. What rate do we use to discount the future? The Stern report on climate change, one of the most influential reports on climate change and what we need to do about it. And the recommendations that came out of the Stern report is that we had to do something about it, but it's very dependent on the discount rate that he chose to use. And there's lots of debate about what the discount rate is. The discount rate means how much you value the future compared to the present. And the higher the discount rate, the less importance you place on the future and the more you are likely to overconsume now. A lot of debate in the economics community and other communities about, because we shouldn't leave it to economists, of course, about what the discount rate should be. We also discount the interests of others. This is not a true picture yet, but it could be our future. Cell phones on airplanes, can you imagine? When your neighbor, I mean, sitting on the train and listening to people talk the whole way is bad enough, but, and you can sympathize with this gentleman. So we discount the interests of others. So intergenerational equity is only part of the problem. We have to worry also about intragenerational equity. We need to consider issues of fairness. This is a picture taken in Sao Paulo. I didn't take it, but I was just there 2 months ago, where very wealthy and rich areas sit right next to poor areas. Great contrast. This shows you the inequity in the distribution of wealth. This is in the United States. This is the ratio of the wealthiest 1% to the median wealth. Already in 1962, that was 125 to 1. By 2004, it was up to 190, and it's continued to increase ever since. So understanding this is a great puzzle, and I'm not going to argue that everybody should have the same amount, but increasing inequity is a problem of great concern in dealing with a wide range of problems. The difficulty is we live in a global commons. Individual agents act in their own self-interest. And the social costs of our actions are not adequately accounted for. Indeed, even if we're concerned about it, most of us don't believe that our own actions add very much. And to some extent, that's going to be true. And so how do you develop a culture where everybody's making only small inputs and could only do small amounts to improve the situation? But yet, if it's like with voting, if nobody went and voted, we'd have problems with elections. So the challenge is, how do we achieve cooperation at the global level? And the problem is free riders like this guy here, who free ride on the benefits, the collective benefits, but don't pay the price. The prototypical problem that people in the economics literature have considered here is the prisoner's dilemma. The prisoner's dilemma says two prisoners who both are suspected of taking part in a particular crime. They're placed in separate rooms. Each one is told there's enough information on them to send them to prison, but if they will give some evidence, their sentences will be reduced, unless the other person gives evidence, in which case they both end up worse off. So if they both end up cooperating with the authorities, that is, defecting from cooperating with each other, they'll both be worse off. What they ought to do is to get together and cooperate and say, we're not going to give any information. But separated, the temptations are too great. And John Nash won the Nobel Prize demonstrating that the only so-called Nash equilibrium, essentially the only stable solution, is one in which both defect. And yet we know there's cooperation in nature, so how do we get there, and what can we learn from this? For public goods, this is called the tragedy of the commons, an idea introduced 2 centuries ago by William Forster Lloyd. The idea is that we share these grazing grounds, but there's a problem in that nobody's got enough interest in maintaining this. This was rediscovered by Garrett Hardin in the 1950s, who wrote a very influential paper. It's been cited tens of thousands of times in science. And this is Elidor Ostrom, who was a colleague of mine, who actually tested out Hardin's solution, which is mutual coercion, mutually agreed upon. We developed cooperative arrangements that police cooperation, and Lynn Ostrom demonstrated this in a variety of applications, in particular in small fisheries, and won the Nobel Prize